Hi, my name is Marek Fořt, and today I would like to talk about building Swift CLIs, aka command line interfaces. But wait a minute, who am I? Well, as I said, my name is Marek Fořt, or Fořt, if you can pronounce that, and I'm a key iOS developer in Prague. I'm also a Twist core contributor. Twist is a great open source tool that helps you with maintaining and generating Xcode projects. And besides that, I'm a Czech Technical University student at the Faculty of Computer Science. And why should I use Swift for CLI? Well, the best reason probably is when you are building a tool that is meant for iOS or Mac developers, and it's either an open source tool or a tool that is for your iOS team at your company. And the reason is simple: it will be much easier for them to help you with the tool and to contribute to it. Other reasons could be that you just love Swift and you want to use it for everything, and as long as it's fun for you, that's a completely fine choice too. And maybe you just want to build something quickly and you want to use the tools that you are already familiar with, and you know Xcode and Swift, so that's a great option too. But maybe the main question here is how do I actually build such a tool? And there are basically two paths that you can take. You can either use, as a building block, you can use libraries by Swift community, or libraries that Apple provides us. I wouldn't say that you cannot combine those, but at least when it comes to the command definition and as the main building block, you have to choose one. Or you could build everything yourself, but I would recommend against that. And today I would like to concentrate on the libraries that Apple provides us. And well, actually we can also ask, how does Apple do it? Because Apple has open sourced a lot of their projects recently. And one of these projects that you probably are familiar with is Swift Package Manager. And since it's open source, we can look at its implementation. And so this is a gist from the Swift Package Manager 5.0 manifest file. And you can see there's the Swift PM name, and then there's a bunch of different targets. Some of them more familiar, some of them less familiar. But I would like to concentrate on these two, Basic and SPM utility. And these two have been actually recently extracted to their own repository called Swift Tool Support Core. This is how they're now integrated in the manifest file in the SPM. And this is how they're packaged in the library called Swift Tool Support. And they have been renamed to TSC Basic and TSC Utility, where the prefix TSC stands for Tools Support Core. Now, a little bit about the TSC Basic target and what you can actually find there. And one thing that we use, for example, at Twist all the time are file paths. That means absolute paths and relative paths. Then there is process for triggering command line commands, terminal control for called output, some output streams, and there's additional extensions and algorithms, so there's a bunch. And this is an example of how you can leverage the paths that are implemented in the basic. And initializing an absolute path is super easy. You just use the initializer with a string and you add a /. And relative path is basically the same, just without the slash. And then you can even combine these paths together via the appending function. You can even combine a path with a string component or multiple components that are input as variadic arguments, so you can even omit the square brackets. And now a little bit about the TSC utility. There are other helpers for CLI development, and mainly there is the argument parser and command definition. This means that every command that's defined in the Swift Package Manager is also defined is used with the TSC utility library. Then there is also a version struct for type-safe semantic versioning, some progress animation, and again, a bunch more. And this is how you can define a command with the TS utility. There's actually a lot of code, and it's a bit imperative. But the bright side is that only 2019 kids will remember this, since Apple has introduced a new shiny argument parser that uses all the new Swift features, such as property wrappers, and it actually offers you with a declarative API. So defining a command is extremely easy and intuitive. So let's look at how you can actually define one command. This is example of an init command. All you need to do is conform to the parsable command, and it actually can be a value type, it can be struct. And then let's say we want to define an option, and we just prepend it with the option property wrapper. Then there's a bunch of configurations that we can do. But the great thing is that if we just want to go with the default, there are sensible defaults set. So for example, here we just want to make sure that there is a short version and a long version of our option. So we have the path with the double dash and the path with a single dash. And the other great thing is that the argument parser is quite smart, and just by defining the attribute, it's able to, just by defining the var path, it's able to parse it into the string version. So it actually uses some magic with mirror, and it's pretty cool if you dig into the source code. And then you just define the type, for example here, it's the optional string. And then you implement the run function where you have all your business logic. And in the main.swift file where all the Swift executables are triggered from, you just use the already implemented main function, which is a static function on your command. And that's really all there is to it, and I think it's much more readable and actually much more fun to write. Now let me say a little something to tests and errors, because I think they are extremely important when it comes to command line interfaces, since developers expect reliable tools, and you can be sure that there is something that will go wrong when working with CLIs. So errors should always have some helpful messages, and it should be always, the developer should always know what his next steps should be when he sees some kind of an error from your CLI tool. And that also means that errors should be treated as first-class citizens. So basically, an error is as important as a feature. And since we always test for features, we should also test for our errors. And with that, now something a little about dependency injection. So to properly test the components separately, we need to inject our dependencies in some kind of way. And we could think that we could simply define a custom initializer. But if you do so, you will get the following error. Type init command does not conform to protocol parsable arguments. And when you look at it, it kind of makes sense. It kind of makes sense since the initializer doesn't expect any arguments. So this will not work. So we took the opportunity to introduce something called services, and that means that every command has its own service. So init command has init service, and other command has other service. You get the point. And here we can just define our custom initializer as we would do normally. And then we have a similar function to the command just called run, where we can trigger some action on our injected service. And then in the init command, we just simply initialize the service and run it. And this way we have solved the dependency injection. And as a bonus point, the commands become plain parsers, and all of the logic is in the services. That means that it's also really easy testable. But now let's go and see a little bit of demo time. So I've prepared already a little project, and it is called Renmoji. And once oh boy, never mind. Okay, so it's a little small, but let me make it bigger. Yeah. And we have a little project called Ranmoji, and it stands for random emoji. And when we run it with Swift run, we will get some kind of an output after it builds. And yeah, we get a random generated emoji, which for this time is rose. And all emojis are taken from emojis.json, which has a lot of defined emojis. Now let's look at the implementation. And okay, so this is the manifest file where we have the Swift argument parser library and the Swift tools support core library. And we have the executable, and then in the Ranmoji kit, this is the place where all the commands are defined. And then when we look at the main.swift file, here we just trigger the command as we have seen earlier. Then we have a model for the emoji, which is decodable, so we can actually decode it from the JSON. Then we have emoji generator that takes as an input an array of emojis and returns a random emoji at a random index. Then we have a file handler helper that's just basically a wrapper around file manager, and it helps us with interacting with the absolute paths. Then we have the Ranmoji command itself, but it doesn't do very much. All the logic right now lives in the Ranmoji service. And here on the top, you can see the injected services. And then you can see that we access the emojis.json from the current path. Then we read the file. Then we decode the emojis. And then we actually generate the random emoji. Let's say that we want to add some additional functionality, and first thing that we can do is to introduce some kind of a progress bar for the user. And maybe we could just do like a loop around on some range and print a next step on each iteration, but that will not work since that will print it on the next line. But if you think about it, Swift package manager has something similar, because when you run Swift build, you will see that there is basically a progress bar as well. It's always regenerating the current progress on the same line, and so it must be somewhere in the Swift package manager. And actually, if you dig through the code, you will find something called Ninja Progress Animation, which is what's used. And this animation conforms to dynamic progress animation. And this has these following functions: update, complete, and clear. And update seems something like we would like to use, right? So there is actually even a percent-based one called person progress animation. And it's a person-based progress animation that adapts to the provided output stream. So that sounds something like we would like to use. So let's go back to the service. And let's see what it can do. Hopefully. Or I can write it myself if the Xcode doesn't work with me. Okay. So yeah, we define a progress animation that takes as an input a stream. For example, for our example is the standard output, which is from the TSC basic library. And then we add some kind of header, which is, for example, generating random emojis. Then we loop through our range, and on every step we generate a new random emoji, and then we update the current steps and with the current emoji. And then we sleep for 1/10 of a second to make to basically, like, we want the progress to be for some few seconds. And yeah, and then we generate the final random emoji. So if we go back and we run Swift run Ranmoji, it will build, and we'll get a cool person animation. And there's just one error, and that is that the generated random emoji is printed on the line of the progress, and that's something we don't want. Fortunately, we haven't used all the functions of the progress animation, and we can see that there is this clear and complete. So we can clear the animation after it's done, and then we can call complete with a success true. And if we run it again, compile it, and voila, the person progress animation is gone, and we get our generated random emoji. But let's say that the user wants only one gender. They want only female emojis or male emojis. So we can add an option for that. So let's head to the random emoji command, and we can add an enum called gender, and it will be a raw value of string, and there will be all genders if we don't care about the gender, and then it will be man gender and woman gender. Okay, and then we can add an option with the property wrapper, and it will be called gender, and maybe it would be like a string, but it would be really nice if it was gender right away. But if we do so and we try to build, we will get some kind of an error, and it says that an option requires that gender conform to expressible by argument. So we can try to conform the gender to expressible by argument and build it again, and everything should pass if the Xcode allows, and it does. And now all we need to do is pass it down to the gender service. Then we can head to the gender service, add the gender here, and then when we are generating the random emoji, we will add it there too. So there is generate random emojis, so we'll add the gender here and a gender here. And the last thing we need to do is actually add it to the generator. So we'll add the parameter gender, and then to the implementation itself. And then what we will do is basically just filter all the emojis from the input. If it's all, then we always return true, and then we check if the genders correspond to each other. So if it's a woman, then we check if it's a woman. If it's a man, then we check if it's a man. And yeah, now it should work. So let's try it, and we will run gender man, and it will build, hopefully. And it seems to really be generating just only men, and we get a male basketball player. Similarly, if we generate it with the woman type, then we only get the females, and we get a female mermaid. So that's pretty nice. But if we run the command as we did before, like this, we will get an error. And that is because actually when we go back to the command, we will see that it is not optional, and we do not provide any default. But fortunately, we can provide a default with the property wrapper with default.all, and if we do it again, it should work, hopefully. And yes, it does. It works just the way it did before. And the last thing we could add is emojis change quite a lot. So maybe the user wants to define their own JSON file, and we could provide it with some path and emojis to .json, some different path from our default one. And so we will do the same process as we did before, which means add an option with a path. This time it will be a plain optional string, as the translation to absolute paths requires some additional logic, so we want to let it do the service. So we just pass it down to the service again. Then we go to the service, add the parameter, like here, and then we add a helper method that takes as an input an optional string and returns an absolute path. And if it successfully unwraps the optional, it will return an absolute path that is relative to the current path. And if it's nil, we will return the default one from before. Now we just need to use this function. And we should be good to go. So we'll again build it, and hopefully it should work. And yeah, it works just the way it did before. But if we now, for example, the user passes an invalid file, we will get a following error. And there's a lot of like boilerplate around, and it's hard to see what actually went wrong. So what we want to do is actually print some kind of custom error to be easier for the user to recognize what went wrong. So we'll use the file handler, which has a method exists, and we will make sure that the path actually exists, and he will throw some error. So we'll define it here, and it's called ranmoji error. It has just one case, that emojis have not been found. And as an associated value, there is an absolute path. And it's a localized error, and so it has a description that parses that can outputs that the argument parses, then it outputs to the user. And if it says just that if it didn't find the emojis, and you should make sure that the file exists. And so we will throw this error, and emojis not found, and we will input the emojis path. And now if we run it, we should get a more sensible error. And yes, we do. And the last thing I would like to do is we want to make sure that there is no regression in this direction. For example, there could be some developer who will be, we don't need this check, the file always exists, and he will introduce some kind of a regression. So we'll go to the ranmoji service tests, and here we have mocked dependencies and then our ranmoji service. And so we will add a simple test case which just says throws emojis not found. And in a temporary directory, which is a function that is defined in the TSC basic, we expect that it will throw in a specific error called ranmoji error.emojis not found. And that will make sure that no regressions will be introduced to our code base. So if we test this and it will build it, we should get a test succeeded. And yeah, so the test hopefully succeeds. It's still testing. The EX code is a little bit slow. Well, that's one bad thing about using Xcode for representations. It doesn't always work the way it's supposed to. But yeah, it doesn't seem to be cooperating. But the test will actually succeed. And we make sure then that no regressions are passed into the code base. And so that's all from the demo. And back to the presentation. And so what we have learned today, we have learned how to use the new argument parser, how we can leverage the Swift tools support libraries, and actually then how we can properly test our command line interface tools and how we can test their errors. So thanks for your attention, and feel free to ask any question on Hopin or on Twitter at Marek Fořt. And